Perfect. So yeah, like I said, we're discussing squat today. Can anybody just tell me what do you understand by when I say squat on ships? Anyone? I'll start picking people now. I just want to get your own understanding before we go straight right into it. Matthew, you can help us. Peter, anyone?
Okay, let me say
Yeah.
squats is a reduction in underwater clearance when a vessel is passing through a shallow water.
Underwater clearance. I would like you to put it in terminology under Q, because it's under Q clearance. It's called the UKC.
Yeah, sorry, under Q clearance.
Q
UKC.
clearance. That's good. So majorly is when the vessel is passing through shallow waters, and the reason why that UKC is quite important is because some people give the definition as is the reduction in draft, and it's an automatic fail because it's not actually your draft decreasing. It's just because the water displaces up and you have a reduction in the under cave clearance. So prior to us going into that, I'd just like us to talk about what are the effects you have on your ship when you're passing shallow waters. What are we going to be looking at when you're passing through shallow waters? Yeah. So when I mean shallow waters, it's more of when the depth of water is less, comparing to the draft of the ship. So if you have like a supply vessel and you have a big LNG coming in, yeah, you should know that shallow water now will be subject to the draft, and in relation to the draft of each of these, the size of the vessel and the draft, of course, of the vessel. So it's just the hydrodynamic forces that will affect the ship when you are handling in different ways. So for instance, if a big LNG vessel is coming, especially coming into Onel Port or coming to Tinker Island, Lagos, or coming into Gibraltar Strait or any shallow place or any narrow channel, their effect will be dependent on the size of the vessel. So this is something that we need to take note of when we are approaching shallow waters. How will it affect your own vessel? So you need to start making preparations for that. And then this effect becomes evident when, of course, the depth of the water is less than 1.5 of the draft of the ship. So you will start having this effect. So for a vessel that is having a lesser draft, you might not have this effect as much as a bigger vessels. And I will tell you all these effects that we are coming into as well. So when we're talking about shallow water, like I said, it's subject to the size of the vessel and to the draft of the vessel. Moving on, in shallow waters, we have different factors here. Thank you. In shallow waters, there are different effects that we'll be having. So one of the effects, of course, will be sluggish movement. And in this slide, we're just going to be explaining why we have this sluggish movement and what causes it. Vibration. Trust me, when you're having vibration in shallow waters, you need to be very, very careful too. Then you have some erratic steering. There will be slow response to your steering. That shows you're inside shallow water. Then there's what they call smelling of the ground. That smelling of the ground, I will still explain it in this lecture too. But the major one I'm going into in this whole lecture will be squats too. Bow cushion and bunk suction effect is when your bow goes in and then your bow goes out and your stern is coming in. We'll explain that, but it might not be today. It will be in our next class, which we'll be dealing with bank effect and interaction too. And also we have canal effect. So I need you guys to be able to understand that, because one of the other questions here is what are the different effects? Yeah, what are the different effects that you will likely face when coming in shallow waters? So it's not just squat, it's not just the bank effect. Of course, we also have things like interaction as well due to the proximity with other vessels in the vicinity. But also we have sluggish movement, we have vibration, we have erratic response because the guy only gave just two responses and the examiner was like, I want more, but he just didn't know what else. Then there's smelling of the ground. Smelling of the ground is not smelling with your nose. I will explain it in the class too. And the squats, which we'll go into today, like I said, back cushion and bank suction effect, we'll touch on it today and deal with it next week more, and canal effect too. Now, sluggish movement, of course, as anybody, I don't know whether anybody has really observed this when they are coming into narrow channel, but it's more of as the oil is moving along the water, you will see that the water which is displaced is not like, it's not instantly replaced, it's not immediately replaced by the surrounding water. So it will create a vacuum. And this vacuum now, as the vessel is moving, then it takes quite longer for the vessel to answer your helm too as well, especially because of the rudder. So this also will also bring, response in your engine movement, and your engine movement will be sluggish. So you need additional more power because you are on shallow waters. But you also need to be very, very careful because we'll still come back to how you eliminate squats here. Is your speed. You mustn't be, your speed mustn't be high. You mustn't be fast. You must really, this is where you need to really put in yourself when they said you need to be, you need to control your speed while you are entering into shallow waters too, as well. I've forgotten the word I was looking for, but anyway, I'll catch it. But yeah, so in shallow waters, we're going to be having sluggish moments, and this is one of the effects when you're having, when you're passing through shallow waters. And two, a vibration. But this vibration, majorly the vibration we have is majorly when you are really, really, really close to the seabed. But in as much as that, you will start having the effect, like I said, when it's less than 1.5 meter in relation to your own draft. So in shallow waters, you start getting vibrations, but the vibrations might not be that obvious, but only when it becomes more and more shallow, then you will start having. Yeah, Matthew, I see you, and I'll back to you very soon. Then also it becomes very difficult to correct a yaw or shear when, with any degree of rapidity when you are also passing through it. And like I said, mostly that vibration, you're almost aground, to be honest, especially when you are seeing it. Someone is asking, is anybody hearing me?
Yeah, I can hear you.
Yes, we can hear you.
Okay. Martin is saying
I can hear you too. I can hear you.
okay. Martin is saying can hear me. Martin, maybe just increase your mic also. But yeah, like I was saying, it's quite difficult for you to control so many things, especially when you're in shallow water. So please, when you are navigating, especially when you are coming in, I'm talking about big conventional vessels. I'm not even talking about only big conventional vessels. I'm also even talking about, small supply vessels, anchor handling vessels as well. When you are coming into when you're coming to the channel or you're coming to shallow waters, please check your chart. If you're using egg discs, make sure you know the depth of the egg disc in relation to your available drafts as well. So, and one thing that you need to be very, very important is there are so many. I was looking at one MAIB, and actually it happened in Nigeria, and it was just because the security boat was actually passing a shallow side, and then this bourbon surfer actually thought, oh, it can pass through that same side as well, and it really resulted to an accident. So to a degree, please make sure we always keep adequate UKC of at least more than 1.5 when we are passing through the shallow water. Yeah, Matthew, go ahead. I'm not getting your question. Yeah, Matthew, can you unmute yourself and speak? Okay. I think we'll move on. I can't understand this question. So yeah, the steering will be erratic. Steering will be erratic, but the thing is, you're not going to really experience this. But when you're like on a big vessels or you're in a small vessels with a relational smaller UKC, you're going to be experiencing this as well. The rate of turning is reduced. Your turning circle becomes larger, of course, and there will be loss of speed due to turning. Loss of speed due to turning is less in shallow waters too, as well. So we need to bear this in mind that if you have vibration, there will be steering effect too, when we're in shallow water. The smelling of the ground, like I was saying, smelling is not by the nose, but this is kind of a good terminology for you to even be able to go down to this extent and tell an examiner smelling of the ground and explain to him. We really know that yes, you understand the dexterity and the implication of really maneuvering shallow water. So this is more of a system where when the ship is nearing an extremely shallow depth of water, put it that way, and there is going to be likely a sudden shear. And what I mean is the shear will first happen towards the shallow side. So your vessel will look like it wants to draw towards the shallow side. Then immediately, violently, it just moves away from it. Like I said, these are things that you might not be able to just quickly observe if you have not gone to an extremely shallow depth. But if for you to go to that extremely shallow depth and you continue going, you might just be getting to a near miss or even an accident, which will result to grounding as well. So shearing is kind of more a case, it first shears towards the shallow side, then violently it moves away from it. So this movement of a sluggish ship may the sluggishness of the ship, which I've told you that the ship will be moving sluggishly because of the vacuum of water as well, because the water cannot be easily replaced. All of a sudden, you will just see that the vessel moves as fast, and then comes back. So it's just kind of a rapid one, astonishingly. And it's just kind of incredibly ridiculous sometimes if you are able to observe it. So moving into the shallow and coming back from violently, I'll put it that way, moving the shallow and coming back to moving to shallow side and coming back to where there's water, it's called the smelling side of it. So it might be any part of the mostly any part of the vessel, but it's more of sharing of the vessel. So I call this terminology smelling the ground too. And this, like I said, it will happen extremely shallow depth of water. And when you get to this place, it's almost a near miss, or it's almost a miracle if you are not going aground too. Now, this is where we're going to. And like someone have just rightly said, squat. What is squat? Squat is defined like the reduction of the underkeel keel clearance resulting from bodily sinkage and change of trim. So it's not just the whole sinkage, it's not just the whole body that comes in. And I'm sure everybody knows the meaning of trim. Trim is the difference between the forward and aft sinkage of the vessel. The forward and aft draft of the vessel, either the forward sinks more or the aft sinks more, and the difference is what we call the trim of the vessel. So it's defined as the reduction on the underkeel clearance resulting from bodily sinkage. So it is not like your draft reduce or increase. No, it's the body sinkage because the water displaces up, and then a change of draft. So going into shallow water, you might be having something like that here as well. You might be having different things, but you might just be having a case where there will just be slight or a significant change of trim as well. And this change of trim is caused by the squat too. Meaning your squat, your aft might just increase, and then your bow goes up a bit, which occurs when a vessel, of course, like I said, is passing through a shallow waters. And like when I mean shallow waters, it starts from when the UKC is less than 1.5 of the available draft too. Then major things that will cause this squat, number one is what? High speed. And that's the thing that's been ringing in my head. Number one, when you're going through so many causes of squat and you're not able to say high speed, you've not started, because that's even one of the actions to reduce the effect of squat. So if you're going through shallow water with high speed, you will experience squat. And I've practiced this before. I've experimented this on supply, no, not supply vessels, on suffer vessels too. And then what really happens is it just creates an area of lowered pressure because there's positive pressure under. And this positive pressure causes the ship to be closer to the seabed than it will be otherwise when expected. So because of the positive in interaction, discuss positive and negative pressure around the ship. The whole vessel has what I call positive and negative pressure, and then when it comes alongside another vessel, especially in the shallow waters, and it's moving with high speed, with very low proximity to other vessels, you will really see that the bow of the vessels tend to move to the bow of the other vessels, or the stern of the vessel tend to move, and this is what causes accidents between tugs and big conventional vessels. Are you getting me? So that's interaction, like I said, but I'll deal with that next week. But the reason why I'm able to say that is because there is positive and there is low pressure. And this pressure is what is acting, especially under the squats. The positive pressure is what is acting under the keel of the vessels, and it's drawing down the vessels, and that's what we call bodily sinking. So the effect of this squat, the effect of this whole squat is directly, I will even say it's really directly. Some people will say it's approximately, but I'll say it's directly proportional to the speed of the vessel. So what I mean by that is, the faster you go, the faster your ship is, the more effect it will have on squat. So the more bodily sinkage you might experience, the more trim that you might experience as well. And also the bow of your vessel, because like I said, it's just how what's the pressure that you are putting, and is there water easily replaced? Like I said, it's not going to be easily replaced. So the bow and the construction, the type of construction of your bow will also affect the bow wave and the distribution of this pressure too. So let's coming back to the slide. Is water displaced by the oil, like I said, is not easily replaced in shallow waters. Let's go back again, sorry. Then the bow wave and the stern wave, of course, will increase in height, and the trough becomes deeper, and the aftermath is drawn downwards. The UKC clearance, the UKC clearance decreases. The UKC decreases, and then the effect. This effect is what we call the squat itself. So if you can really see it right from the beginning, it's more of the bow pushing against the wind, and it's just creating more positive pressure. And this more positive pressure, it comes from from under the keel, and it's bringing what I call a positive pressure, like I said. And because the water is not easily displaced, we have the bodily sinkage of the vessel, or we have the trim of the vessel. So when you've described this to an examiner, the next thing he wants to tell you is, how will you know you are experiencing squats in shallow waters? Or this is even something, I think when I was working with Tom Ocho, that was one of my questions I like to ask my OWs to as well. So this is quite most of the questions in interview. How will you know you are experiencing squat? Like I said, it still goes down to the same thing on effect of shallow waters. It will be sluggish. You will still experience that sluggish steering. You will still experience that little, especially that little vibration. You will still experience little rolling and pitching. Your rolling and pitching, of course, will reduce. And then the turning diameter of the vessel, of course, will reduce. But more importantly, because now you're even in shallow areas, you will see mud showing up around your vessel, your ship. Or like I said, it's not really obvious, and it's all subject to the size of the vessel that we are putting and the speed of the vessel too. Let's go down into the arithmetic or the technicality of this. I put it down here saying the ship side, the ship speed, of course, is directly proportional to the square of the speed. Squat, sorry, is directly proportional to the square of the speed. And I tell you, I tell you this, some might say it's approximately proportional, but the reason I'm saying directly proportional is whatever you do with your speed will determine the effect it will have on your squats too, as well. So you can see it from the whole calculation here. There's no need for you to get this calculation into your head. But majorly, what you should just understand is your squats in relation to your block coefficient. So when I mean block coefficient, I mean the bow of the vessel, the construction, the way your vessel is being constructed too. In relation to your speed, then in relation to the depth, available depth under, it will now give you the effect that you have on your squats too, as well. So that's why for vessels that are supposed, fast craft vessels that are meant to or are designed to be running in shallow waters, you see their bow really constructed in a way that it fits the memorandum of that person. It fits the cosmo of that particular job. And it fits also into the criteria in which it will just reduce the squat effect. So if we are able to go with high speed and you are able to reduce the block coefficient in a way that it allows it allows the effect of squats, then we might be able to reduce the squat effect. But you're carrying a big conventional vessel, you're bringing it in and you're running with so much speed. There are so many things you're going to be damaging as you're approaching shallow waters. It's not just for you, but for other vessels. You're going to be experiencing squat, you're going to be experiencing interaction, you're going to be experiencing bank effect, like I was just explaining previously too. So majorly, what are the actions to reduce squat from everything I've said? Can someone help me now? Actions taken to reduce the effect of squat. Anyone?
Speed, Captain.
Sorry, you're breaking up. Oh, you're breaking up.
Yes, sir. You can do that as you said by reducing the speed.
Reducing the speed, proceeding at a safe speed. That was the word.
Yes,
Reducing the speed. Thank you.
Yes.
Another one. Anyone? Is it just one? Any other person? Okay, I'll give you a clue. Where can squats take place?
At a shallow water.
So what can you do as the navigating officer when you are making your passage plan?
You should make sure that you go into the deeper side.
As much as possible, go into the deeper side. Yeah, thank you, November Alpha. It's a proper use of the echo sounder as well. But the echo sounder, I must really say, the echo sounder tells you where you currently are. So for proper planning ahead, by use of a proper passage plan, we'll be able to tell you, okay, let's navigate here. Oh, that side is shallow. There's no need for you to take a risk, because even though the underpin clearance, you might be having a lot of underpin clearance, but yet you might still be having the effect of bodily sinkage. So please, let's not risk it. So that's what I'm saying as well. So because some people, like November Alpha is very correct, use of echo standard, but you don't want to get to that place before you realize that you're not even supposed to be there as well, if that makes sense. So yeah, slacking your come again.
Use of your squat table also.
Yeah, use of squat table.
Yes, sir.
That's one, but it's to be honest, it's not really common, but it's also very good as well. Then use of your tight table is very, very, very important too. You might be going in high tide, you might be going in low tide too. So you need to be very, very, very conversant of the tide of the area that you are going to too. One more. This cannot be us. I mean, this is not something that we, the seafarers or the navigating officers, can control, but it's something from the construction yard. One more method or action to take to reduce squats from the shipyard. Anyone?
Constructing
Sorry, I'm not. Yeah, someone is saying something. I'm trying to get that person. Yeah, Olatobi says continue fixing operation and proper lookout. Yeah, proper lookouts. Thank you. We've talked about that. There's one from the shipyard that we are missing. If you look at this, huh?
Flat bottom.
The bow, how the bow is built.
The bow. Thank you very, very much. Because like I said also, the type and the bow construction will affect the bow weight and distribution of the pressure. The bow construction, the way the bow is being constructed, will affect the wave that is being pushed. It will affect the pressure that is being accumulated. It will affect the effect, which will later affect the effect of the squat. And that is why we are seeing here the squat will be sequence to block coefficient times velocity to velocity. In this case is of course the speed in knot, and then we're looking at, okay, let's go over 100, which is of course the over 100 to try and get what effect to be on the squat too. So the block coefficients in this case, or we can put it the construction of the bow in this case really help us a lot, especially when you are going at 10 in shallow water. You will face a lot of effects. If someone just tries it, you go at 10, especially when you go at 10 with full speed, then you really know the effect of what we're trying to discuss here. But if you go ahead, yeah, you might really feel it, but you will not really feel it as much as when you really go at 10. So if you notice, if anybody is going at 10, especially in shallow waters, you really see so much vibration. You can even start seeing mud going. Then you can even see the stern of the vessel. All this mostly is I just keep using this example because I've worked there before on bourbon surfers and Otai and cat splash. You really see it on that side as well. You just see this tank really going as stand too as well. So yeah, the construction of the bow, proper passage planning, avoiding shallow waters as much as you can. Make sure you're navigating in the deeper side of the channel. And most importantly, reduce speed, proceed at safe speed, which is very, very important when we are trying to avoid squat. I'll pause here. Any question? Right. Let's go again. What's on my slide I have not said? Yeah, very important. Thanks. The squats may cause grounding in spite of enough UKC. So yeah, like I was telling someone in the class, you might say, oh, there's enough UKC, and you might be checking your echo sounder, but actually it's more of telling you where exactly you are. So lack of proper planning ahead, lack of proper passage planning might result in grounding, even though you have enough UKC. So please, let's not take this thing lightly. We need to put it and look at the dexterity and the severity of any accidents that will happen in case of any squat effect that has been left underlying without paying due attention to it. Also, squats must be calculated beforehand. Squat must be calculated beforehand. So these are one for the guys using echo sounder. Please don't be more reliant on echo sounder for the squat. I'll really tell you that, for example, please don't bring out the echo sounder as well from all the explanation that have been that I've highlighted here. So it must be calculated beforehand. It shouldn't be when you are there, then you are still checking too as well. So that's why we talk about proper planning and proper preempting of what will happen. Then speed to be reduced to reduce squat. So when you are experiencing all those things, you reduce your speed. But even before proceeding inside a narrow channel, even before proceeding to shallow waters, a knowledge and enlightenment of all this and a full understanding of all this will make you know that no, even I am proceeding right there from the open waters down to shallow waters, I am still meant to reduce my speed because I will start facing squat, because I'll start facing bank effect, because I'll start facing suction, because I'll start facing interaction, all those kind of things like that. So while determining the UKC, squats for the speed to be taken into consideration. So that's another thing. Like I said, the squat is the bodily sinkage of the vessel itself. It's the bodily sinkage of the vessel. So when you are doing your passage planning and you say, oh, I still have 2 meters 2 meters UKC while I'm proceeding under, when you've calculated your draft and calculated the available depth of the water there, you also need to put in effect for squats too as well, or else you might end up grounding. So that's why I'm saying that proper planning ahead, because of course your company, I don't know, everybody has different different company procedures when determining the UKC for, your minimum UKC when navigating in any water. Some company UKC might be 2 meters, some might be 1 meter too. But all these things are just, like I said, to just prevent grounding. But when you are trying to calculate at all times, and you're trying to plan your passage down to make sure that at all times you are proceeding at a UKC of minimum, let's say of 1.5, you need to put in effect that there will be squat. So when you are going to shallow waters also, there should be considerable amounts of allowance being put into and being considered to say, okay, by the time I get here, then I might be having a squat of 1.2. What do you do? What do you start doing? This is something that will go down to a deeper side of the water, not just neglecting the fact that, oh, there might be reduction, and then you are still looking at still proceeding on a shallow with the 1.5. So all these things, like I said, should be put into consideration too. And yeah, this last one was kind of like an answer that made an examiner smile, which is when determining the UKC, the squat for speed in shallow waters. That was the answer. The squat for speed in shallow water should be taken into consideration. So yeah, when determining your UKC, like I said, squat for speed in shallow water should be taken into consideration. This is where I'll be stopping today, which will be bow cushion and bank suction effect. The bow cushion and bank suction effect. It works more or less with what I just talked about now, squats, and it's kind of more, we'll do more of it in the main lecture next week, which will be interaction. But like I said, the whole ship has a positive, negative, and positive pressure all around it. Your vessel, if this one is a vessel, mostly the bow has a positive pressure up to the side of the vessel, the port and side, we have negative pressure, and then at the stem. And then we have also a law of magnetism, which says positive and positive attract, and negative repel. Positive, negative attract, and negative repel. So like I said, we will go down into more details, but honestly, coming into bow cushion and bank suction effect, what does it mean? This still happens, this majorly happens in our channel, but we're still going to be facing the shallow waters too as well. So this is when a vessel is coming in, trust me, there will be a tendency for the bow of a ship to be pushed away from the bank. And this is called bow cushion. So for instance, if you are coming in straight, and this is what happens, especially at the ports here, Aberdeen ports and any port, even in Onel port. I remember when some incompetent, I would just say just have some careless navigational officers just proceed in with a tanker of 20,000 gross tonnage, and they're proceeding in with a great speed as well. Then you will just see all the mooring lines just trying to come up, and even sometimes some of the mooring lines of the vessels we're going to be cutting. This is when you are just negligent of the fact that there is what we call a bow cushion and a bank suction. A bow cushion and a bank suction effect. Because what is going to be happening is the bow of the ship is going to be pushed away from the bank. The bow of the ship is going to be pushed away from the bank itself, and this ship will move. Like I said, now this ship body will move towards the bank, and it will appear as if the stem is moving away from it, and that's when we now call the bank suction effect. So what am I trying to say? The stem of the vessel goes towards the bank. When I mean bank, it goes towards the pier, it goes towards any other vessels there, and the bow of the vessel pushes away. So this kind of yeah, this kind of uncontrolled movement, and it's quite rapid, and it's in a way that it also affects anything that come in his way, is what we call this bow and cushion effect. And honestly, it really causes accident. It causes accidents in narrow channels, it causes accidents at the ports, it causes accidents, especially all this is in shallow waters, by the way. And this is caused by a restricted flow of water. Like I keep saying from the beginning, I was saying that the water, if it's not really easily replaced, then it causes so much pressure, and this pressure itself now starts causing some other effects that might even cause accidents if you are not aware of it. And the velocity of the water to the bank increases, and the pressure will reduce, of course. Then results in drop of pressure level towards the bank, and as a result, a thrust is set towards that bank. So a vessel approaching to the bank, we have to apply M to the bank to reduce the speed to prevent the shear from developing. So it's more of another maneuvering that you need to do if you are faced with those kind of things, especially for smaller vessels when they are really faced with those kind of situations too, as well. This diagram here is what I'm trying to talk about. If we can see it there. So the suction, I put the suction as something it draws you. So it draws the stern of the vessel towards the bank, and then it pulls away the bow. So it pulls away the bow away from the bank too. So you'll be having a case where involuntarily, and it's not a situation where you want to find yourself. You find in a case where your stern is steering towards the bank and the bow is pushing away. So the bow pushing away is what I know term it as the cushion effect, and the stern coming in, and it's going to be really big. Especially if the stern comes in really fast, it's going to be a suction effect because the bank draws in. But like I said, this mostly happens when you're passing through a bank, you're passing through a pier, you're passing through a port with high speed, and you are negligent of this fact of bank cushion and bank suction, sorry, and bow cushion effect. Mostly, like I told you, it's more of the pressure that we'll be facing too. Canal effect, I will not go into that tonight because I would like to do that with the interaction. Did anybody get my lecture on the squat, bank cushion, and the bank suction effect?
Yes, sir.
Yes,
Perfect.
sir.
Perfect. Yeah, perfect. So now for the bank cushion, what can you do to prevent this? Anyone? The guy that said yes, Master Marina. Let's go.
It will reduce speed.
Sorry?
Reduction of speed will help in
Reduction of
reducing the bank effect.
exactly reduction of speed. It will reduce the bank effect. It will reduce that bank suction and bow cushion effect. Please. Then also, this only happens in shallow waters. So we need to put that in our answers to try and say, okay, as much as possible, we will navigate through the deepest side as well, as much as possible too, as well. But like I said, this back cushion bank suction, it's not subject to the construction of the vessel, I mean of the bow of the stern, but it is a factor that affects each and every single one too, as well. Then applying M to the bank. Thank you very much. Applying M to the bank. November Alpha. So for your bow cushion effect, like I keep saying, your bow is pushing away, your stern is pushing in, which is your stern is being sucked in. So what you need to do is, of course, reduce your speed. Try and aims to, if the bank here, like in this case here, it's in the starboard side, aim to starboard and try to keep the vessel straight as much as you can. The lower you reduce your speed, the lower you reduce the effects on the vessel itself. All right. Thank you very, very much. I think it was really a very, very nice interactive class. If anybody asks you of bank cushion, bank suction, and squat, you should be able to tell them what causes it, the effect of it, how to reduce it, and what to do if unfortunately you find yourself in it too. Another important factor for you to know is shallow waters does not only, the effect of shallow water is not only limited to the bank effect or squat or interaction, but these are also other effects that your vessels will face. If there is sea room, stay midstream while sailing through a narrow channel with shallow water. Mastermind, I don't understand. Is it a question?
Sir?
Master Marina, you asked if there is sea room, stay midstream. Oh, if there is sea room, yeah, stay midstream. Okay, why sailing through a narrow channel? Yeah, thank you. If there is sea room, yeah, stay midstream. Don't go towards the shallow side. Don't follow in Nigeria security boats, total security boat, movie security boat, and so. But yeah, coming back again to this. These are effects that will face in shallow waters. Please, sluggish movement, vibrations, erratic steering, slow response, smelling of the ground is not smelling, is only just a rapid movement when it shears and when it shears away. I mean, it shears towards and shears away from the bank. Then we have, of course, our squat. We have the bank cushion, the bank suction effect, canal effect, and then we'll discuss on interaction next week too, as well. All right, thank you very much. Does anybody have any question to ask?
Yes, I have a question.
Yeah.
So, for example, if we are going into the port, usually pilot will ask, what is your freshwater draft? So now, why is it that we don't put this squat into consideration in giving out the draft? So you understand my question?
I'm trying to get it especially when you say freshwater draft, because we should be dealing with sea water density and dock water density here.
Yes, that is when you are giving the draft, but still when you are giving your draft, but that draft that is in the freshwater draft that you're giving, it will be like when the vessel is not moving.
Yeah. Oh, yeah.
So now, if you are moving, if for example your seawater draft is 7 meters, while your freshwater draft is 7.2. Now, when you are moving to the jetty, due to the squat, it will increase.
Sure.
Yeah. So now, why is it that we don't consider that when giving out the draft?
It's different answers here. I'll first start by saying the draft, nothing will happen to the draft, it's just bodily sinkage. One, I just want to correct that phrase.
Okay.
Two, when we are moving, I'm sure whether the pilot itself would think, the pilot will be looking at your UKC. Yes. That's another aspect that he will be putting in full consideration in checking your draft, and then of course checking the available depth of the water itself. So when he's trying to get your own draft, majorly the most important factor of the most important question and the most important condition that the pilot will be looking at is actually your current draft currently now. Yes. And then what he's trying to also look at, of course, would be more, your dynamic and your static drafts too. Then putting all these calculations into place and computing them, you'll be able to really assess what will be your UKC when you are flying through, all the shallow water. So what I'm just trying to say, okay, for instance, now you've come down from seawater, maybe you're in the dock water, or you're still using your seawater draft, depending on whichever draft you're using and the density of the water that you are using as well. Majorly, why the worst case scenario for your UKC, the pilot will be considering it all along. So that's why I'm sure it's not going to only collect your freshwater draft, it's also going to collect your present draft as it was boarding. True or yes?
Yes, yes. You collect your
Collect the present draft.
as well as
And him himself, if he doesn't know about the area, but I'm sure a pilot of course will know about the local area. He knows the available depth of water there. So what he wants to maintain now, and every pilot has different methodology that you're using, bringing the productivity of this out in play. But what they're trying to discover now is how much can I, as much as possible, increase the UKC of the vessel, increase the UKC of this vessel. But also, you need to appreciate the fact that, there are uncontrollably, there's no way we can be able to neglect the fact or completely eradicate the fact that there will be some shallow waters where the UKC is really slow. So now these pilots, with their own local knowledge, having this mindset in mind of the squats, of banking effect, they will be able to start knowing, okay, even though the UKC is low, I know what it will do. And that's when you see them going with a very low speed, bearing in mind your draft, bearing in mind the available depth of water, bearing in mind the UKC, bearing in mind that they have started observing the squats itself, but they are able to walk through it too. Are you understanding?
Yes, sir. So now, would your draft increase as a result of squirt?
No, your draft, nothing happens to your draft as a result of squat. It's not called reduction in draft. It's not called increase in draft. It's called a bodily sinkage. Your calculated draft, it still remains static. It still remains dynamic, and it still remains the same thing. But it's just the vessel going down. It's just the pressure, because of the pressure that you are having under the vessel, it sinks the vessel down, and it's called a bodily sinkage. So it has nothing to do with your draft. Your draft comes back to what draft you've been able to calculate prior to departing port, or when you are at sea, if that makes sense. Because there is no displacement that change. Your displacement on board the vessel does not change. It's your displacement in relation with other conditions, of course, and in line with your density, that will determine your draft. But major factor for your draft, of course, will be the displacement too, as well. And in this case, there's nothing that happened there. This is just an effect based on the positive pressure that you are experiencing in shallow waters and in confined spaces too. Do you understand that?
Yes, sir. Yes, sir.
Mastermind, go ahead.
Good evening, sir.
Yeah, good evening.
Okay, sir. There's something I learned some time ago back in school on how to prevent or reduce the probability of having a bow cushion or a bank suction. Like when entering the channel, for instance, if you're going against current, that it is best when you're going against current that you should be close to the other end of the channel before altering your course, so that the current will push you towards the midstream, or because the current, you are going against the current, and the current will push you when you alter course. So it is best we move our vessel close to the other end of the channel, so that when we alter course, take for instance, now we are altering course to starboard, and the narrow channel we're entering is at our starboard bow. Then when we are going, we should go close to the end of the other bank of the channel side, before we alter our course. Starboard, sir. Okay, yes, sir. The port side of the channel.
Yeah.
Yes, sir. So before we alter course, so that the current will push us. But then if we are going in favor of current now, because we know once we alter course, the current will still push us ahead a little. So we should alter our course to the starboard side of the channel before, not that much. Once we just pass the bank, let's say a bank, 1 or 2 cables, then we alter course to our starboard, and then the current will push us to midstream. So that's just the contribution I had, sir. Just, I don't know if I'm correct. I stand to be corrected, sir.
Yeah. It's making a lot of sense because I've done it well, but I must really say it has little relation or correlation with banking and with banking and cushion effects in the because what we're trying to achieve by that, and especially if you have it in supply vessels. I mean, you have it in your supply vessels if you're on DP vessels when you're going alongside the reef. Sometimes I just stop and allow the current to just push me alongside. So all those things are more of maneuvering tactics when you are trying to consider the wind and the current in maneuvering too as well. And especially it happens in the Bonny Ferry boy too. You need to understand where the current is coming from or going to, especially if you are coming close, or else it will push you towards it. So what I'm trying to say in excess is, especially when you are maneuvering, you need to really understand, just like you're just trying to tell me now, but it's quite different from the banking and cushion effects, honestly. But it's more of you understanding where the wind and current is coming from and using that to propel your vessels accordingly. So let's say, for instance, now you, like you said, you are turning to your starboard and you are walking against the current. So let's say you are on the blow on zone. It's just once you are close to the starboard side and you're trying to turn, trust me, you're going for a downfall, because it will just, both the current, and especially if you have the current and the wind, you will not have enough maneuvering room to turn. It's just going to blow you straight down to the pier. So what you need to do is move away quite as much as you can before you start turning. And by the time you turn, you even surprisingly see that the current and the wind has even blown you much closer than you have expected. So more of all these things are, to be honest, are maneuvering tactics here, because those have got nothing to do with they have got nothing to do with the shallow waters, because even though you are at open sea there and you are dealing with an offshore installation, and you're trying to turn not considering the wind and the current, it might result to an accident, if that makes sense. So that's very good, but do not limit it to shallow waters, because it's not more of this effect, but it's more of maneuvering when having the wind. Of course, you always have the wind and the current, but especially when they are of significant effect, if that makes sense.
All right, thank you, sir. Yes,
Yeah.
it made a lot of sense, sir.
All right, thank you very much for Master Marina, to Peter, Osman, Mohammed, Lema November, Afolabi, everyone. Thank you, sir. Thank you, sir. We'll see you next week.
Sir, please add me on your WhatsApp group, sir, so that I can be getting an update.
Okay, okay, you know what? Do this for me. Just send me a chat and I'll add you this.
I just drop a message for you, sir. Okay, I'll drop my WhatsApp number again.
I've just sent you my number.
Okay, I will add you, sir.
Yeah. Sorry, remove the 0. I forgot to remove the 0. But anyway, all right then. Thank you.
Which 0,
see
sir?
you guys next week. International. Try and read as much as you can, and to be interesting.
Which 0 should I remove?
The 0 after the +44.
Okay, copy.
Okay.
Well, thank you very much, sir. We really appreciate it. God bless you.